Alright, here we are back again with a little bit of algebra. We're in Chapter 6, Section 4, talking about exponential functions. This is Part 2. I didn't want to overwhelm you in the previous part, but previously we looked at exponential functions that are in this form, where we have a variable with the exponent. So we actually went through and graphed this one, 4 times 2x. You can make a table. Here's that table. If I plug in -2 for the exponent, I would get out 1, right? Because that means divided by 2 squared. That's 4 divided by 4. That's 1. Then if you plug in -1 here, that's 4 divided by 2. That's 2. Plug in 0, that becomes 1. And then that's 4. Okay, so now we can graph these. Notice, if I plug in 0 for x, 0 for x gives me whatever a is. So a, in our exponential function, y equals a times b to the power of x. A, if x is 0, then a is my y-intercept, 4. So graphing that, I know that a is 4. Also notice that b here is 2, and we are multiplying each of these factors by 2, so times 2. So if I'm given a table like this, I can write an equation using the y-intercept for a, right here, so that'd be 4, and then b would be what I'm multiplying by, that common factor, 2x. And remember, f of x is just a nickname for y, so I can put y there. Okay, if I want to graph this equation, now we still have 4 and 2 here, but now we have x minus 3 plus 2. Again, I could make a table and plug those in. Now really what I want to look at is describing the domain and range. How is that different from the previous one? Well, the domain is the x values, goes on in this direction and keeps going on in this direction. Even if it's steep, it keeps going this way, so it's all real numbers. While the range, notice that it's no longer down here, it has moved up, and the line that it's getting closer to is 2. That's what we're adding to it right here. So the range is all values of y such that y is greater than 2. Alright, if we want to graph an exponential function where b is a fraction, so it's between 0 and 1, we'll plug in these values here. If I plug in -2, plug in -2 here, that flips the fraction and squares it, right? So that gives me 4, but I have a negative in front of here, so that gives me -4. Then if I plug in 1, -1 would just flip the fraction, and then we have a negative, so that's -2. 0 means this is 1, so that makes that -1. Plug in 1 here, we get -1/2. And plug in 2, if I square this, I get 1 squared over 2 squared, which is 1/4, and there's a negative out in front, so -1/4. Then I want to graph those, -2 and -4, -1, -2, 0, -1, 1, -1/2, 2, -1/4. We can see what's happening here. It's getting closer and closer. We draw a curve. Remember, it never touches the x-axis. Describe the domain and range. Domain is, again, because it keeps going this way and it keeps going that way, is all real numbers. And the range, we can see it gets closer and closer to the x-axis. Right, here's the x-axis, but it never touches the x-axis. So it's y is less than 0. All right, here we have an example, bacterial population. The graph represents bacterial population Y after X days. Write an exponential function that represents the population. Okay, now I'm going to use these numbers here to make a table. Okay, so I have X and Y. I'll make a table. I have 0, 3, 0 for X, 3 for Y, 1, 12, and then 2, 48, and 3, and 192. And I could write the fourth one, 2. I might not need it. Let's see. 4 and 768. Now, if I want to write an exponential function, remember we had y equals a times b to the x power. Okay. I have to find the common factor. 3 times what gives me 12? 12 times what gives me 48? This is times 4. Check the next one. That's also times 4. Okay, so the common factor is times 4. That's b times 4 to the x power. A was the y-intercept, so a is 3. So y equals 3 times 4 to the x power. Now it says find the population after 12 hours and after 5 days. Okay, well this down here is in days. So if I want 12 hours, I need to express that as a day. How many days is 12 hours? That's a half a day. X is my days, so I'm going to plug in a half for X. So I'll plug in a half for that exponent. Y equals 3 times 4 to the power of a half. Remember, a half, that's a square root, so that's 3 times square root of 4. 3 times 2 is 6. So the population after half a day is 6. That's somewhere right about here. Population after 5 days, notice that's not even on this chart anymore. I'll put in 5 for x. Y equals 3 times 4 to the 5th power. And I'll type that in my calculator. 3 times 4 to the 5th power. And that gives me 3,072. So that's exponential growth for you. After half a day, we're at 6. After 5 days, the population has grown to 3,072. There you go. That was part 2 of exponential functions.